Yes, students, good morning. Hello, students, dear students, how are you? I hope you are fine. And we are in continuation with the video lectures based on work energy power. In the previous video lecture, that is part 7, we had discussed about the mathematical equation of kinetic energy, and after that we had discussed about the relationship between kinetic energy and momentum, and based on that we had discussed 3 numericals and CRT numericals. Based on that we had discussed. Now today the most interesting and useful topic, which is evenly used at various places in physics, in your board examination as well as in your competitive examination, that is work energy theorem. So try to understand the concept behind the work energy and theorem. So let us start. Work energy theorem. Work energy theorem or work energy principle. Work energy theorem and work energy principle. So dear students, this theorem states that when there is change in kinetic energy of the body, then work done on the body is equal to change in kinetic energy of the body. Means this theorem relates the work done with the kinetic energy. I want to explain explain it with diagram, and after that we will discuss about the work energy theorem for constant force and variable force also. Then let us understand. Suppose there is a block of mass m. There is a block of mass m which is moving with initial velocity u. And a force is applied. Okay, so if a force is applied and the body is moving with a constant velocity u, then if a force is applied, then it is obvious that you know that when a force is applied on a body, then its velocity is going to be changed, and it acquire by traveling certain distance, it acquires the velocity v by the application of the force, because there is an acceleration in the body of block, there is an acceleration of block of mass m by the application of force v. So initially the kinetic energy is half m u square, that is kinetic energy initial, and final kinetic energy is half mv square. So according to work energy theorem, the total work done in the body in moving from its initial position to its final position is equal to kinetic energy final minus kinetic energy initial. And the work done is called as delta k. This work done is called as delta k. So this is about the work energy theorem. Now dear students, we are going to discuss about the work done by constant force. Work energy theorem for constant force. work energy theorem for constant force. So first we are going to discuss about work energy theorem for a constant force. Constant work energy theorem for constant force. So we are going to discuss about work energy theorem for constant force. So dear students, again I am drawing the same diagram. Suppose the body of mass m, this is the body of mass m, and a force is applied, and the initial velocity of the body is u, and it has traveled a distance, it had traveled a distance s and reached the position, reached this position, and here the final velocity of the object is v. Final velocity of the object is v. Now using the expression, since you are aware here the body is moving, body is changing its velocity, means the body is accelerating, it has the acceleration. Write it. If the body is changing its velocity, means it has acceleration, body is accelerating under the effect of force, f, the body is accelerating. So using equation of motion, final velocity is known, initial velocity is known, acceleration is known, distance is known. So using equation of motion, you know that the equation of motion, dear students, you are knowing the equation of motion, that is v square minus u square is equal to 2as. This is the equation of motion, dividing both side by 2. Dividing both side by 2. When you are dividing both side by 2, then it will become what? V square upon 2 minus u square upon 2 is equal to 2s. Multiplying both side by m. Multiplying both sides by m. On multiplying both side by m, if you are going to multiply both side by m, then the equation, this equation becomes what? 1 by 2 mv square minus 1 by 2 mu square is equal to here a is equal to MAS, and if a force is applied, then F, since the force is applied, then we can write as F is equal to MA. Since force F is applied on the block, since force F is applied on the block, so we can write it as F is equal to what? F is equal to M into A. Putting F is equal to MA in equation, suppose this is equation 1, this is equation 2, this is equation 3, and this is 4. Putting 4 in 3, putting equation 4 and 3. Putting equation 4 in 3, we will get what? Half mv square minus half mu square is equal to F into S. And you know that force into displacement is what? S is the distance covered or displacement, and force is acting in the same direction. So it can be considered as the work done. So we can write from here. W is equal to half mv square. It can be written as kinetic energy final, and half mu square it can be written as kinetic energy initial. So from here we can write it as work done by the constant force is equal to change in kinetic energy. Work done by the constant force is equal to change in kinetic energy. So this is the work energy theorem we had proved under the action of constant force, under the action of constant force. Because dear students, this force F is not going to vary from this position to this position, that is from initial position to final position. The applied force F is not going to be varied. So it is considered as the work done by the constant force. Now we will concentrate our discussion for the work done by the variable force. Work done by the variable force. Work energy theorem for variable force. Work energy theorem for variable force. Dear students, next is the second case is work energy theorem for a variable work energy theorem. Work energy theorem for a variable force. Work energy theorem for a variable force. It means to say that the force is varying, the force is changing from its initial position to final position. For the body moving from its initial to final position, the force is going to be varied, the force is going to be changed. And for the force going to be changed, force is of varying nature. So we will consider a small distance ds for which we will consider the force is acting as a constant force. Means, suppose, try to understand this. This is a block of mass m and a force is applied. And this force is of varying nature. So we will consider a small distance ds, for which we can assume that for this displacement, whatever the force acting on the body is of constant nature, and we will consider the work done in that case is dw. So suppose a variable force acts on a body of mass m and produces a displacement ds in suppose a variable force F acting on a body which produces displacement displacement S in the body, which produces displacement S in the body. So for a small displacement ds, for ds we consider f as constant, f as constant. So what we will do, we will calculate dw is equal to f into ds, theta is equal to 0 degree, because force and displacement are in the same direction. Rate of change of kinetic energy, rate of change in kinetic energy, rate of change in kinetic energy, how the kinetic energy changes. So look at here, kinetic energy is what? Half mv square, half mv square. So rate of change of kinetic energy, it means to say that dk upon dt, and dk upon dt can be written as mass is constant, so 1 by 2 m into twice v, m into dk upon dt is m, since you are differentiating with respect to t, so half m twice v into dv upon dt, because you are not differentiating k with respect to v. If you are differentiating k with respect to v, then it will be simply 1 by 2 m into 2v. You no need to write dv upon dt. But since you are differentiating kinetic energy with respect to time, and here there is no any variation of this function with time, so one time you have to differentiate this with time also. So 2v into dv upon dt, this is the rule of mathematics. So we can write it here as dk upon dt, so now dear students, look at here, dk upon dt is equal to half m 2v dv upon dt. So this will be cancelled out, and now what will happen? Look at here, dk upon dt is equal to m into a, and you can write dv upon dt. You know that since dv upon dt, rate of change of velocity is acceleration, so we had placed dv upon dt as a into v, and you know that from Newton's second law, dk upon dt is equal to f into ds upon dt, because v is equal to rate of change of displacement. Now it will be cancelled out, and we can write here as dk is equal to f into ds, dk is f into ds. Now as we had assumed that this force is of constant nature, so now integrating it from the initial kinetic energy to the final kinetic energy, and the position xi to xf. So look at here students, means if here the kinetic energy is ki, and here the kinetic energy is kf, and here the position is xi, and here the position of is xf. So in order to calculate the work done, what we have to do, integrating both integrating both side. So look at here, dk and initial kinetic energy ki and final kinetic energy kf, which is equal to f into ds, that is initial to x final, initial to x final, and you can write it as into k final dk is equal to k, and it is equal to k initial to k final. So it is equal to x initial to x final f into ds, and it is equal to final kinetic energy minus initial kinetic energy is equal to xi xf f into ds, which is, this is equal to work done by the variable force. We had calculated this expression x initial to x final f into ds is equal to work done by a variable, work done by a variable, this is work done by a variable force. So we can write it as work done by a variable force, work done by a variable force, work done by a variable force, that is equal to change in kinetic energy. Work done by a variable, that is x initial to x final f into ds, that is equal to change in kinetic energy delta k, change in kinetic energy delta k. This is the work done by the variable force. Now dear students, we will discuss certain conclusions behind the work energy theorem by the variable force. We will discuss certain conclusions, that is work done by constant force or variable force, work done by constant force or variable force is independent upon Newton's laws, Newton's second law. Note, work done by a constant or variable force is independent of Newton's second law, is independent of Newton's second law, because dear students, as you know that we had calculated F is equal to ma, we had considered F is equal to ma, and then we had proceeded, in both the cases we had proceeded towards our result. So work done by the force is always depends on Newton's second law. And the second thing is that force is a vector quantity, but work done is a scalar. Work done is a scalar, means whatever the work done or kinetic energy we had got by the help of Newton's second law is a scalar result. So this is all about the work energy theorem we had discussed for the constant force and variable force. Now we are going to discuss certain numericals based on work energy theorem.